and the way it works, it doesn't perform asynchronous operation is really right. So the question arises that okay, given all this stuff, basically, what is first of all what is asynchronous? First of all, what is asynchronous?
Okay, so
So let us
we already started with linked list, right? Okay, so how is it going? Like, on which topic you are currently?
that
Okay, so okay, so you have reached DP, right? That's good. That's good. So, like, you're just currently revising on like all the topics again, right? Uh, yeah, yeah. Like, so like all the stack trees queues are completed, right? Okay, okay, okay. Got it, got it. So, okay, so let's see some more questions on linked list. So I'll quickly share my screen and let's see what we have already discussed, and then we can. Yep, yep. So let's go to the code. So we'll just reload this page. Okay, so we saw that why are we learning linked list basically? So basically, let's say that we have memory and we can store some elements in it. Okay. Now with the array, we have restriction that we need a single, like we have continuous stretch of memory where we can store elements. But with linked list, we don't have any such limitations. So in linked list what happens is element is stored along with the address. Now what we can do is we can try to link one node to the other. Okay, and we can just proceed with that part, right? So this is what this is what linked list is, right? So you have an element and we have an address of the next node. Now what is the node? Basically the combination of element. Okay, the combination of element and the address it is holding for the next node, it is called as a node in the linked list. Okay, so this is what it is. Now we have certain pointers we'll see. So something called as head, something called as tail, you for the traversal of our linked list. Okay, so that is what we will be using. So there's something called as generics which we do not need to see right now. Okay, so when we study oops just after linked list, then we can come with that part also. Okay, so if you want, so what you can do in the course questions, that you can just go to the main code and you can fetch some idea how basically the things are framed. Okay, so you can get some idea from here how input is taken, how basically the class of linked list is made. Okay, what are the things we need to import? Okay, and all those sort of things. Okay, so with that being said, I guess we are good to go with some more good questions over here. Okay, now this is a palindrome linked list. So we were going to solve this problem last day, but I guess we didn't do this. Now what we already know from the current discussion is we can already fetch the length of linked list by traversing it. Okay, we can put a pointer which goes at the end at its null, print the ith node using the for loop. We can to achieve this. Okay, inserting node in the linked list, guys. Okay, so inserting node in linked list, are you guys clear with this approach? How you can insert a node in linked list? Okay, okay, that's good. That's good. So the basic idea would be just to traverse and place the key over there, right? Okay. Now deleting the same thing. Okay, so just point, like make your pointer, make your current pointer move to next dot next, and that is it. So just whatever the middle element was there, you do not point to it anymore, and that will be. So if you do not point to a node, okay, so what happens to that node? Is it still there? Okay, okay. So let me write the code here so that we can have a clarity. So going to Java. Okay. Now let's say that I wanted to delete. So like one, two, okay, three, and then we have four. So and this is the uh, null. Okay. Now, in order to delete three, what we did in the last session is we made it two's next point to two next dot next. Right. This is what we did, right? Okay. Now, when two next point to four, so two next is not pointing to three anymore. So three is just pointing to four. So what happens to three? Is it still there? Very correct, very correct. So it is garbage collected by Java itself. Okay, so any unreachable memory location, so Java keeps looking at that and it frees that space. Okay, so that is the point. Okay, so we can move with the next question, but before that let me drop a message to the guys that we have already started. So we'll say, okay, so yep, that is it. Okay, now let's try to like add a recursion to the linked list because we are already have studied recursion and now it's time to use that part. Eliminating duplicates from linked list, I guess these things are easy, so we can discuss it later. Okay, printing print a reverse linked list. Okay, so let's do this part. Print a reverse linked list. Now, how can I print this linked list in reverse fashion? Any ideas, guys, from your end? So the output I am expecting here is the output I am expecting here is 4, 3, 2, 1. So what are the ways do we have? What are the methods do we have? Okay, okay. So okay. So you can see that print ll. Okay, give me a minute, guys. Okay, so the one solution for this question comes as I want to print the linked list in a reverse fashion. Okay, the one question from her, sorry, the one solution from Harjit comes as you can use the recursion for this. Okay, so let me quickly create a class over here. It will take a minute. Okay, and it will be a good practice for you guys also. Okay, so you can create your own classes. You not have to rely on like predefined classes. So we okay, we'll discuss that part later. What do we have linked list already there or not? So that is separate discussion. We did have, but yeah, it's good to have knowledge from scratch. So let's say that int data. Okay, and you can say node next over here. So we have a node over here and the data over here. So we can create a node. So you can say node n1 over here. Okay, and probably have a constructor over here. Okay, a constructor will ले लेते हैं. So we'll say int data. Let me do this quickly. So and we can say this dot data equals to data. So if you remember, this points to the current object. Okay, this current object को point करता है. Now this n1, in order to create a new node, simply whatever you write over here. Okay, जैसे आप पहले से लिखते हो, so you can just do the same thing. Okay, Okay, now we can say n1 dot next equals to new node. Okay, so I'll just copy the syntax so that we quickly have a data over here. So copy this, paste this, paste this. Okay. Okay, this is okay. Looks like I need to have so node n2, node n3. I'll just save it, guys, so we do not have to create this again and again. So don't worry. So that's n4. This is one time thing. Okay, normally n1 dot next is equals to n2, right? And n2 dot next is equals to n3, n3 dot next is equals to n4, and that is it. Okay, so if you do not point to something, it is automatically pointing to null, right? So you do not have to take care of that. The point is printing it in a reverse fashion. Okay, one ways to use recursion. Okay, so what is required here, guys? If you want to use recursions, what should I pass here? Okay, so exactly which node should be passed here? Okay, very correct. So pass the n1 node. Okay, so here comes our print function. So print, okay, so print ll. So what should be the data type here? So what should be the data type here? Do we want to return something? Node or for printing. Okay, okay. So we do not have to. Oh, thank you. Yep. So we do not need to return something. Okay, we can say that node head. Okay, receiving the head over. Okay, so let's use recursion. What should be the base case here? Is what should be the base case? Head equal to null. Okay. So how many of you agree with this part? Is this correct? Okay. Yep. So this is correct. So this is a good base case. Okay. Now we know this thing. ठीक है, ये तो हमें पता है कि we have to write something like this. So print ln, ठीक है, print ln, and you have to do head dot data. Okay. So while having recursion, the three things we have to figure out: number of recursive calls, edge case, not edge case, base case, number of recursive calls, and the parameter you have to pass in the recursive call. So where should I mention my recursive call? Above print statement or below print statement? Okay, okay, okay. All of you are getting the point. What Hasib just said. So why should we using this first? Mm-hmm, mm-hmm. Exactly, exactly. So we want to print when we return from null. Okay? We do not want to print when we are going to the end. We want to print when we are returning from the end, right? Guys, all of you are clear with this part? Obviously, non-static method node cannot be referenced. Okay. Don't worry, we'll cover this in oops. Okay. So yeah, this is the point. Okay. And if I just so what happens if I place that call below the system printout element? What will happen? Correct, correct, very correct. Okay, okay, so let's download this and let's not delete this part at least, or we have already downloaded, so we can just edit this part. Now this question is like, okay, this is very easy. Now, why we did this? Because we have to do one more question. Do we have this question here itself? Palindrome linked list. Okay. Um. So we discussed for a solution in palindrome linked list. We said that we can traverse the linked list halfway, and for the next halfway, we can get the reverse of our linked list and compare those two. So I exactly don't remember who gave the solution, but yeah, obviously. So this question, this seems to be working. The solution seems to be working, right? So this is very easy. So how to reverse linked list? Ideas are open with both a recursive approach and iterative approach. How can we reverse a linked list? Input is this, the output should be this. So how can we do this? Any ideas? How can we reverse the linked list? Okay. Think in such a manner, think for two nodes first. Okay, if you guys are thinking, so think of two nodes first, that one next is 2 and 2 next is null. Now what is the expected output? What is expected from you guys is this should become something like this. Kuch aisa ho. Think of these two. Now head is given to you. Okay, head is given to you already. So how can you use this? How can you reverse two nodes? uh Guys, two nodes is easy. Okay, can I say that one dot next is equals to one? One dot next equals to one. Can I say this thing? How many of you agree with this line? Guys, are you with me? Hello? Guys, are you getting the point what I'm trying to say? At the Okay. So if I want to do the reversing in two nodes, so I can say one dot next is equals to one. Okay, and yes, yes, obviously, okay, and we can say that one dot next equals to null. Okay, so this is what we can do. So the first approach which I already have is the recursive approach of reversing a linked list. Recursive approach of like reversing a linked list. Let's see that part. Okay, so currently what we are having is 20, 10, 20, 30, 40. Okay, now instead of the sprint function, let's create our reverse function. So reverse ll. Okay, reverse ll, pass n1 over here. Now node, and yeah, we can just whatever reverse side we get, we can just reiterate over it and learn over it. So we can say int I is equals to 0, or it would be better if we directly use the while loop. So while, okay. Okay, let's write the reverse logic first, then we can take it. Static rev head. Okay, so I want the head of new linked list. Okay, so I want the head of the new linked list with a reversed, like a reversed format. Okay, so what should be the data type, guys? What should be the return type over here? Very correct. So we should be having node over here. Okay, now the things we have to figure out is what is the base case. Can this be the base case? Now, why I've written this? So if our linked list is null, we cannot reverse it, right? We need to have at least how many nodes to reverse? Okay, like one node, right? One node is means the itself, right? Okay, so the base case will be node dot next equals null. Are you guys getting this base case? Okay, so if you have a single node, return that part, right? Okay, Harshit, are you getting this point? Okay. Now my point here is whatever we were doing for a single node. Okay, whatever we are doing for a single node, what does recursion say to us? Recursion says to us, sir, please do the code for the current part, okay, and let me handle the rest. Okay, so do the code for the current part and let me handle the rest things. Okay, so this is what we want. Now I can say here as node rev head. Okay, so let's name it revh. Okay, so we already told, like, since we are going to iterate. Okay, okay, so this is the reverse. This is the reverse head we tend to get. Okay, from like whatever the recursive calls are there. Okay, so moving forward, now for a single node, what we write that if head is the node, what we want to say is head dot next head dot next dot next head dot next is equals to head. Give me a minute, guys. Okay, so for the current node, we just have to take care of the current node. Okay, so if head is at so if head is at 1 and we want to reverse this, so head dot next is equals to head. Okay, and head dot next equals to null, so head dot next equals to head, and head dot next is equals to null. This is for the current node. Okay, you do not have to take care of anything else. This will be taken care of by recursion itself. Okay, and we can return the reverse head. So what happened here exactly? So okay, we are doing so when we are changing the node while going to the end, or while returning from the end, when we are doing this operation. when we are correct. Okay, so when you are returning from the back, then we are doing the operation. So recursive call at 38 line, and the logic is here. It means that what interviewer will ask next is, sir, please have a drive in. So you can say the interviewer. So let's say that we have something like this. Okay, this is the node we have. Now this will reach at 40. That is it. Okay, nowhere else. This will reach at 40. The first thing to hit here is 10. Okay, so your first thing to hit here is 10. Then the next call will be to 20, then to 30, and finally to 40. And this is what it is. Okay. Okay. The point is, the point is, you have reached here. Then you'll meet this line because you are doing all the operation when returning. So 39 number line will be executed when all the 38 is done, and you have met this base case. So you are returning from the base case. Okay, so you are at 30 now. So when you are at 30, so you are doing this. So your head is at 30. So 30 dot next, which is 40. So 40 dot next should point to 30. So what you are doing exactly is you are saying 40 dot next is equals to 30. As you are getting this step, how many of you get this 3 point? Like the first 39 number line will do is make 40 next is 30 and 30 next is null. How many of you are getting this? Or should I repeat? Okay. So since as we enter in this function, the first thing is the recursive call. Okay. So when you will reach line number 39, when all the recursive calls are complete and you are returning from the base case, right? Okay. Yes. So whenever you enter this function, so it call head dot next, then you again enter, so you call it. So when you are at 10, come here, then you make the call to 20, then you make the call to 30, then you finally make the call to 40. But when you make the call to 40, the base case returns you the node. Okay, returns you the node in rev h. So rev h receives what rev h receives? Okay, which is 40. So rev receives 40. So what is so the first return here is 40, right? Okay, and the line number at line number 39. So line number 39. So you are returning from 40 to 30. Now your head is at, so 30 dot next, which is 40. 40 dot next, which was null. Now you are pointing 30 dot 40 dot next again to head, which is 40 pointing to 30. Make sense? This part. What is okay? So head is 30 and head dot next is okay. Dot next equals to head means okay. So head dot next, which was null. Now you are assigning 40's head to correct. Correct. So this is the first reversal, and you are making the head dot next as now 30 is pointing to, and what we are returning, which we received here. Now we are returning back to, now what will happen over here? So 30, okay, and will now who will point to null? 20, right? Now head is at, yeah, okay, and what will return here? Did we change rev head? No, right? So what will receive here? What will, so when you will return to,
or basically call it a sequence function or a vector because
so
particular or timer, timer for handling
here,
checking instantly
what will return now?
and there can be possibility that there are
Then finally you
multiple
will return to rev head. So what you will receive in rev head?
right? And even to
So like
just
one time
want
40, right?
to say one more part,
Yeah, the last 10
this
will
is what
return
is
40.
very important
Now 40 is pointing to,
right? So this whole process
30 is pointing
what we
to,
are going to do, right? So we will look at
20 points to,
exactly
at 10
the
points to.
concept of very important concept that we are
So is the linked list
very very
reversed?
important and very easy to understand. But I think we would come
So
to
guys, are you
very
getting the
much
point?
be able to understand this and this is at higher level
What about other guys? Guys, all of you are getting the code here.
and I think that's how the whole right, this architecture, this whole concept of understanding and LAPI allows us to perform this simple concept using the concept of recent using also using the concept of how
Okay, so whatever reverse head you receive, you just try to add it over here. So it says no dot next, it says non-static variable. Okay, what's that? What happened? So non-static variable cannot be a reference from a static constant. Non-static variable cannot be referenced. Okay, cannot find symbol. Okay, reverse LL. So did we create the function name correct? Okay, no. And the same thing over here also. So reverse linked list. Okay, and what do we have now? So what errors are remaining? Now static variable cannot find name. Variable name class chef. So can I make the class static?
that make this
Hmm.
and I would say that all algorithms
Okay, let's check for this one. Yeah, obviously you cannot have it over here. That is a good point. But what should I do? So it is not allowing this to be as the return type. So what should we do? So we have node over here and and so non-static variable cannot be referenced from a static function. Non-static variable. Non-static variable. Oh, okay, okay. This is what we are missing. So it should not be node dot next. It should be head dot next, right? Similarly, here we should be returning the head. Okay.
and yeah, this question first from Anand, what do you answer?
Program within is no output, and why is that? So rev head, well, rev head not equals to null. Okay. So we have successfully reversed our linked list. Okay. Yep. So guys, all of you are clear with this code over here. Okay, that is good. Now here comes the second part of the question. Okay, now you're given a problem. The next problem comes here as 10, 20, 30, 50, 30, 20, and 10. Check for palindrome. Check for palindrome. I will just download this file. Okay, the question is how can we use the reverse logic to check for the palindrome? What's the idea here, guys? Okay, now reversal we already know. Can I do this? So I can make half the linked list. I can half the linked list, and what can I do? I can half the linked list. Okay, so I need to check for palindrome. I already know the reverse logic. So can I half the like half the list over here, reverse this list and compare with my list? Can I do this? How many of you agree with this? Okay, so let's do this part. So okay, now we already have these number of nodes. Let me add three more nodes to this. Yes, M5 and 6 and 7. So okay, we can so just quickly form the list. So n4 dot next is equals to n5. Give me a sec, guys. Okay, so n4 dot next equals to n5, and 5 dot next is equals to n6, and n6 dot next is equals to n7. This is what the complete list is. Okay, now I do not want to reverse, I do not want to print it. All I want is to check if the list is palindrome or not. So let's do this part also. Oh, you already have this function, right? So reverse logic function we already have with us. Okay, so getting the list of our link list. So length ll. Okay, so let's create a function for length. So we can say int len. Okay, and I can pass the and one over here. We create a function. So creating function is always helpful so that you can use this. You can use that same piece of code again and again. So what's the whole point of creating functions, guys? What's the whole point? Whole point is reusability, right? So say that if head dot next equals null. So what should we return from here if I'm counting the linked list? Length. What should I return? What should be the length of a single linked list? Okay, it's head dot next. Head dot next means there is only. Okay, so what should I return? Length. Correct. Very correct. So if you have a single link, like single node, so its length will be one. right? Okay, now what I can return here is 1 plus 1 plus length ll. What should I write here? Head dot. Correct. Guys, are you getting this logic? That's it. Guys, okay. So every time you make the call, so 1 plus, so finally you will return 1, so 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5. That is it. So we need half of the length as it is, and rest half to be reversed. Okay. Now, how we can do that is, any ideas how we can reverse the second half of the linked list?
So it will start with the hello. So let's say that in 5 seconds, in 5 seconds, can it go to the next line of code? It won't go until this is violated program, correct?
Can I write like this? I divided by length plus 2, I plus plus. So let's say that the length comes to be 7. Okay, the length comes to be 7. So 7 divided by 2, which is 3. Okay, and 0, 0, 1, 2. Okay, so 0, 1, 2. So the first 3 will be there, next 4 will be reversed. And you can say, okay, you can make a temporary pointer. So
How you can answer this
okay, so you have a temporary pointer so you don't lose your head. Okay, temper this. Now you can say that temp dot say temp equals to temp dot next, right? And I can, so once you reach at the midpoint. Okay, so I need to make it equal to, so that I get that part. Okay, it's half of the list. So I will say second half. Okay, so second half, and I can say reverse linked list. Okay, so what should I pass here, guys? In the reverse linked list, very correct, very correct. First half is as it is. Second half to be reversed. Now we now we have n1 as head for first half, and sec half as head of second half. Nothing we require here is just a while loop. Okay, and we can say that we can say that so we can say that n1 dot next not should be null, and second half dot next not equals to null. Okay, now if n1 dot data equals second half dot data. Okay, so if it is equal, so it's all good. So, or if it's not equal, I can say not system. I can directly write the into part. So not a palindrome, not a palindrome. Okay. Okay, so let's test this, guys. Let us see if we are on the. It says compilation error. So it says cannot find symbol second half. Obviously, because we have to do this. What are the other cases? Second half cannot be fine. Second half cannot be fine. Then I guess it is good. Then let's see. It says time limit exceed because why it is saying time limit exceed, right? Guys, are you getting the point? Why I am adding this two lines? Okay, so we have to move our pointer first, otherwise it will cause a infinite loop. Okay, so it says a palindrome. Let me do some changes here. Let me do some tweaks. So I will say 70. Okay, 70, and let me run this. Not a palindrome. Okay, let check for what do you say? Let's check for even length. So for even length, we can just do this. Okay, for even length, we can do this, and let's check for this. So M7 does not exist. Okay, obviously it's not a palindrome. So just for the condition checking, we are doing this. So it says not a palindrome. And what if I intentionally make it a palindrome? So for intentionally making it palindrome, I can do 30, right? 30, 20, and 10. So it is 10, 20, 13, 30, 20, 10. Let's check this. And it says a palindrome. And just one last case 30. Okay, so it says a palindrome. Okay, so here do we have some problem? I guess we have some issue. So 10, 20, 30, and 10, 20, 10, 30, 30. So okay, okay, okay. Let me print these two notes first. I can say n1 dot data plus sec half dot data. Okay, so let's try to print this and let's see what we are getting exactly. So 10 and 10. Okay, 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 okay. So what is happening here? So it is just comparing the first part. If it is not equal, return. Hmm. So what happened here
Not possible
exactly?
to understand because it just running the line, right? So this is that's why you got the this is the answer and
So, okay, for checking this part, let me console this one. So, what I'm getting over here is, so let's check the length. Let's check, uh, let's check temp we are passing. Okay, temp dot data. Okay, let's print this. So, the length and the temp dot data part. What
yes,
exactly temp we passed here?
there will be this the further
So 6 is there and temp dot data is 30. What we are passing.
and
So length is 6. Okay, so 6 and let me make it 40 and okay. So which 30 exactly it is sending? So 10, 20, 30, 50, 40, 10. Okay, let's check. So length is 6 and we are passing 40 as mid. 40, 40. So where is 40? Oh, okay, I see. You not have to pass 40, you have to pass 50, right?
ask my plan
Have
when
to
he just
pass
started
50.
and as well as after 1 year when I switched to this plan. So these are just all the questions that were asked in my plan all
Let's check this part.
so yeah, I'll go from there. So what are the
So,
question
okay.
related like
Okay, so it says not a palindrome. So now 50 is passed. We are getting 10, 10, then getting 20, 40, then 20, 40. Okay, so I guess we have solved this part now. And let me make it palindrome. So I'll make it 20. Okay, and make it 30. Let it be 50. Okay, so let us add one more check to this. 50, 20, 10, 10, 20, 30. So it should not be palindrome, right? And the third part also, okay, so it is saying a palindrome. So 650 to 10, 20. 10, 10 compared, 20, 20 compared. Okay, so why are we not comparing 30? 30. So why not 30? Why not 30? Okay, so 30 and 50 is compared now, and it is not a palindrome. Okay, let's make it a palindrome. So, made it a palindrome and run it again. So, check it. So, it should give palindrome now 10, 20, 30, 30, 20, and then. Okay, so yeah, it is passing our code, and there's a couple of changes we did, right? Okay, so what we did see in the same logic. So traversing, comparing it, creating a length function, reversing the linked list using recursion. Okay, passing passing the midpoint and all these codes. So guys, is this part clear to all of you? Any doubts with the discussion? Okay, so let me share the sheet with you. So as we do have February. Okay, this where is it? Do I need to get it? Yep. Because if you have the link, please mark it. Otherwise, I will just share it. So today we have 28 and 5, and this is Saturday. So Saturday. Okay. So let me share the link. Okay. Okay, I have shared the attendance with you guys. Please mark your attendance. Okay. Okay, guys, let's meet tomorrow. And if you have any doubts regarding the questions or the discussion, please feel free to ping. Otherwise, we'll discuss it tomorrow. Okay, guys. Bye.